And I'm in. Hi, everyone. Welcome to Barclays Eagle Labs. So people that are new, welcome. For the guys that have been before, you're going to hear the same old spiel that I'm going to give. So two things. Toilets through the door. Lovely bit of housekeeping. Down the stairs, just follow it all the way around. Second thing, we shouldn't have a fire drill today. If we do, follow me out the door. We go to the Joker pub. So that's as easy as that. But welcome, yeah. So welcome to Barclays Eagle Labs. We are a business incubator. We are also a co-working space. So where you're sitting here this evening is where we co-work. Barclays Eagle Labs was formed, 10 years ago now? And we are a business incubator. So we want to help businesses grow and scale. So if that is something interesting to you, come and speak to me. And, I can put you in contact with people that can help, whether it's mentoring or one of our accelerator programs. Everything that we offer is free to help you and your business grow. That is our main thing that we want to do. One of the other things that we have launched is our Eagle Labs Academy. So at the moment, we are in Entrepreneur Week, which is an amazing week to help entrepreneurs grow, scale, and move forward. If anyone wants to know, this is a learning platform. Again, it is a free service that we offer. Zap the QR code that's at the bottom, register, and just have a look through. There's so much good content on there that we have put on, and we are adding to it on a sort of monthly basis. So that's it from me. If you want to speak to me, I will be about, but I'm going to hand you over to the lovely Oscar to set off the proceedings for tonight. So enjoy.
Thank you, Andy. Thank you very much. Thank you for hosting us year after year. We're very grateful to Eagle Labs for this. I'm sure you agree this is a wonderful space. You can just walk right off the street into it, and it's so close to the train station, so central. And also, thank you for the upgrade. Usually I'm Oscar. Today or tonight I shall be lovely Oscar. I am much obliged. And to all of you, welcome to the Brighton Data Forum. Special shout out to our remote audience. Thank you for tuning in. And if you have any questions, any comments, use the chat feature, and the lovely Cam over here will pass them on to us. Right. So it is fantastic to see new faces still coming. We're still attracting new attendees to our events. And that's not to say that I'm tired of your old faces and the repeat audience. Very glad to see that you know exactly what's coming up, you know who we are, and you still take off an evening or Wednesday evening to spend with us. The Brighton Data Forum, we are a skill sharing, socializing, and networking community of data professionals in the broadest sense of those terms. Data, we cover all aspects of data, from database administration, data collection, data ethics, data science, engineering, you name it, visualization. Yeah, it is our belief that if you work in any of those fields of data, if you're a data professional of any stripe, all of these aspects are of interest and relevance to your work. We work with professionals from all stages. We have in our membership executive suite members and interns. We especially welcome the participation of enthusiasts and students of the data world. The Brighton Data Forum's home address is on meetup.com. Presumably you signed up right there. But we also have a secondary home on Slack. In between our events, we hold the conversation going on our Slack workspace. And so please join that, and you can hear about our special events that we try to fit in between our regular events, which are always on the last Wednesday of the odd-numbered months. So we meet every other month, odd-numbered months only, and it's on the last Wednesday night that we get together. And now I'd like to give thanks to Richmond Mead Consulting. They have been supporting the event for a couple of years. Sorry, Paul, could you get the door? Somebody, oh yeah, you got it, thank you. And Richmond Meet has been supporting the forum for a couple of years now, solid, very solid support for which we are very grateful. They are a globally recognized analytics company and a knowledge center on all things analytics and especially all things Oracle. They, even if you're not working in analytics or Oracle, I do recommend you check out the blog on their site, because they post fantastic content, really highly curated content on all things data, you know, from strategy to implementations to data science to engineering, you name it. So yeah, so whatever you're interested in, you will find one brilliant blog post there. So thanks to Richmond Mead. And now the Brighton Data Forum is a proud member of the Silicon Brighton umbrella and tech community. And here to tell us about that is the lovely Cam.
Thank you, lovely Oscar. Hello, everyone. My name is Cam, and I work with Silicon Brighton as their events and community coordinator. Let's go with that. And yeah, we are the hosts of Silicon. Oh, no, I always get that wrong. We're the hosts of Brighton and Hove's digital tech sector, proudly hosting to all of these meetup groups that we support. Many of which I've seen a lot of familiar faces now. You take full advantage of the variety of events that we host. And yeah, if you see any events here that you would like to get part of, join us on Meetup, come chat to me afterwards. We just want to say a big thank you to the Silicon Brighton supporters who assist us with what we do. They help us out with our live streaming capabilities, which we're zooming in on. Hello, everyone. And yeah, they just assist us either with volunteer or their spaces or financially. And it's just honestly such a help to bring everyone together. And we're really proud of that. A giant thank you to our sponsors as well. More of the same with an even more invested approach to it. And we're really happy with them. So thank you very much to our sponsors. And finally, we've got this link tree that gives you access to our website, all of our events upcoming, and our very cool Slack channel that you can join the discussion after the events, during the events. We post things like jobs, opportunities that are all really exciting to take part of. And it's how I try and organize the absolute madness that is organizing 40 meetup groups. So yeah, I think that's all me, except it's not. There's more. The festive meetup at the Old Albion and Hove, we've got that coming up on the 11th. We'd love to see as many of you as possible. So I'm ringing out, well, it's not really ringing out the end of the year, it's ringing out Christmas. So yeah, that's me really. Thank you very much, guys.
Right, and so we're almost ready for the main event. And I'm pretty excited because I've been looking forward to this for a long time. And we are finally addressing spatial and geospatial data analysis. And we have 3 great talks lined up for you. But you know, for some reason, for all the data talks that I see, spatial data analysis tends to be sort of underrepresented, at least in my circles. I don't know about the rest of you. But the way I see it, the role and the objective of data is to represent a real world fact somehow. And spatial data places that fact or those facts in context with each other and relationship with each other. And I think that context and that combination of the factoid and the context is a really powerful one, and you'll be seeing examples of that. So I just find this very fascinating and quite rich in potential. So you answered a survey when you signed up for this event, and the results of that is very close to half of you have had some experience working with spatial data. Now, this is a bit of an embarrassment for me to see because this is our first event focused on spatial data, with the first talks that we give on spatial data. So I have a twofold hope to come out of this, that the people out here who already have experience come talk to me about future talks with more spatial, so we can have more spatial analysis in our future events, and don't neglect this subject so much as we have. And the second is that the rest of you who have yet to touch on spatial data now get some curiosity and some interest in this, in the potential that this extra dimensions add to your data sets. So, and with that, let's hear from our first speaker. That's Sean Burton, Geospatial Data Analysis, a consultant from Azura Earth. Give him a warm hand. Yeah.
Like this, yeah? Oh, yeah. Right. Hello. Right, I'm just going to give you an intro, really, to the geospatial world, or certainly my experience of it, and give you some, yeah, examples of where I've actually been now using it commercially. I'm a data engineer, have been for most of my life, mainly in the retail sector. About 8 years ago, and I love maps. I've always loved maps independently. And about 8 years ago, someone said to me, "Oh, you must love GIS." GIS, never actually heard of it before. Looked it up, and suddenly this whole world opened up. People actually do data and maps, and they earn money from it. And so suddenly, I wanted to make my career more interesting and bring that in. But what is GIS? It's well, GIS stands for Geographical Information System. Any spatial system that deals with, well, points on a map, routes, or indeed polygons, whether that be areas or building footprints and things like that. And at a very basic level, a point is just simply represented by a set of coordinates, you know, an X and Y, or in this case, what the example here is just simply a longitude and latitude, latitude in that order, which is very important. Line string is just simply a set of those points, an ordered set of points, which then describe the actual path. And a polygon is really a specialized version where the last point equals the first point, so it's a closed loop. You can do more things, you can punch holes in your polygons, but that's essentially what it is. And you can represent this as plain text like you're seeing there, or it could be in various loads of different formats, as you can imagine: geopackages, shape files, all sorts of GeoJSON, all sorts of different sort of formats. But in terms of technologies, where do you start? Well, take your pick. There's tons of stuff. I think most people in this room hopefully use or may have touched on some of these technologies. Being a data engineer, I was very much on the SQL side. So Postgres has its own GIS extension. So what that means is, rather, you know, when you're doing your joins and you're kind of like joining two tables on a field with the GIS extension, you can then start storing geometry, and then you can actually do spatial joins. So rather than joining, like I say, on a field name, you're actually doing an ST intersection, these ST functions between a point layer and a polygon layer. How many points are in this polygon? I don't use Python, but Python's got obviously its own set of libraries, GeoPandas being obviously one of the main ones. I use R a lot, so simple features is a key one for me, along with dplyr. And then, of course, you've got all of your visualization libraries as well, your DeckGL, Leaflet, which have their own wrappers in the Python and R world as well. I put QGIS in the middle there because it was the key thing for me that really got me into the geospatial world. It's an open source application. You can just download it, and it highly visual way of just simply crank it up. You can say, I'll have an OpenStreetMap background, and then you can download stuff from Ordnance Survey and start pulling it in, seeing the actual dots, the polygons on your map, and even then start doing processing, you know, count how many points are in this postcode area, for instance. So you can experiment and visualize things from the start, and then decide to do whatever you want in your own programming environments. Okay, so first thing I had to get my head around when I started getting into this was the coordinate systems. Latitude, longitude, that's how it works, isn't it? You know, you've got your globe or your oblate spheroid, and everything like Eagle Labs is 50 degrees north of the equator and 0.13 west of the meridian. That's how you describe places. Started looking at, obviously, Ordnance Survey and all of their data they've got, discovered this thing called British National Grid. British National Grid is what Ordnance Survey did was, rather than, because the UK is a relatively small curvature of the Earth, you can pretty much put, you know, flat bit of paper on the globe. Where it touches the paper, we'll call that grid north, one of the meridians, and then project onto that bit of paper. And what then you end up having is this wonderful Cartesian grid. You choose we'll choose a false origin, which is west of the Scilly Isles, and then that means we can express everything in meters east or north of that origin point. So suddenly now it's a lot easier to express points. So there's Eagle Labs. It's 105 kilometers east of our origin, and 5. I think I've got that the wrong way around. Anyway, see, this is one of the problems. Yeah. There we go. Yeah. So and obviously then what that means is then your maths become a lot easier. If you've got 2 points expressed as British National Grid, you're to work out the distance, you're just doing Pythagoras. You're doing real simple maths. So really lucky with Ordnance Survey, we've got that. But also then when you're working with these different coordinate systems, it means actually you can very, very easily go wrong. As I found, this was actually an example a few weeks ago. We're not talking about 8 years ago. It still happens even today. So we were dealing with a whole load of point of interest data across the UK, and it was all divided into the different regions of the UK. When we came to the Northern Ireland one, we plotted it. We cranked up QGIS like we usually do. Let's get it in. 2 columns in a CSV file, X and Y, and we thought it was British National Grid. So we put it up, and then all of a sudden, yeah, that's not Northern Ireland, that's somewhere in England and Wales. Closer look, okay, it looks a bit like Northern Ireland, but on its side, they've flipped the X and Y, just like I did in the previous slide. So you flip the X and Y, so okay, fine, let's put it back round again, great. Next step, no. Now we've got something that looks and scales a bit more nicely towards Northern Ireland, but actually it's in the north of Wales. Again, what's going on there? Well, it turned out that actually this wasn't British National Grid. They were using the Irish grid, which is very similar to the British National Grid. It's just simply a different origin. So luckily one of my colleagues spotted that. We then sort of like brought it in again into QGIS, assuming 29902, the Irish National Grid, and suddenly we have everything in its own spot. So that, like I say, regularly happens. One of the things I often do is my nice map of London, I end up plotting in the middle of the Atlantic because I've assumed British National Grid, but actually it's just lat long or long lat. And on that subject, when you get your lat longs the wrong way around, you end up then plotting somewhere in either the Indian Ocean or just off the north, I think, coast of Brazil. So again, usually when you visualize it, you see it, you understand, and then you correct it. Okay, and then so talking about the British National Grid, very interesting when you start using it in practice. Generally, I don't have to worry too much about this as a data engineer, but if you're an orienteer, you're a hiker, you've got your nice Ordnance Survey map, it's important to know that your lovely vertical lines on your Ordnance Survey map don't all point north. In fact, only one of them properly points north to the true north. And that is actually where the grid was originally established, on the 400-kilometer east line or 2 degrees west. So you can see where we are in Brighton, it's slanted slightly. So your nice straight line on your map actually isn't really pointing north, it's actually offset. You've got to take that into account. Except that's not the whole story. You've got your compass. Your compass points to magnetic north. Magnetic north is the weird one, of course. It's the one that's been wandering over the past few hundred years in the north of Canada. It's now accelerating towards Russia. It's come all the way across. In fact, apparently it's the closest it's ever been to the true North Pole. So you go straight north from here and then just go a little bit south, and there it is. Because of where it is, it's crossing this nice grid north line. So what it means is if you're orienteering, I think the actual exact point is somewhere north of Manchester at the moment. If you're orienteering there, what you'll find is your compass will be pointing to true north, which will match exactly your grid north line. So quite exciting, the GI circles. It's only going to be the case for another year, and then it sort of, at the moment, I believe it's accelerating something like 30 kilometers a year towards Russia. So we'll see how that pans out. Right, then, so how do we, so that's the coordinate systems, but how do we then visualize the data? There's many different ways to visualize it depending on how you're then going to project it. These are 2 maps of Europe, 2 recognizable maps of Europe. However, the one on the left has actually used a conical projection. So here we're using, instead of, we're putting almost like a hat, a cone on top of the Earth, matching it to a couple of lines of latitude and then projecting up. So it's still a projection, but it's a more accurate view of what Europe should be. The one on the right isn't wrong, but it's using the Webb Mercator projection. And that's where you kind of, that's the flat map of the Earth, the thing that you've got to pull it out and stretch it. And when you look at them side by side, you can clearly see part of the problem. Scandinavia, Iceland get a big upgrade. They look a lot larger than they should be. Spain and Turkey, slightly sort of like smaller, but also the orientation's all off. And because it has to be, because of the way it's stretched out. What we find with the Webb Mercator is important because it's become kind of the de facto standard, because that's what Google use and all of the main digital providers. In fact, some of the libraries that you will only actually use this. But if you are dealing with kind of continental level type visualizations, it's usually better to go to some sort of conical projection like you're seeing there on the left. That's a much better view of what Europe really is. Because the extreme example are things such as Russia and indeed here Canada. Again, if you're a Canadian map maker, you wouldn't be using the Webb Mercator. You would be using another conical projection that you're seeing there. That nice straight 49 north latitude isn't really straight. It's a great circle. It curves around the Earth. So, and again, you can see the distortion, this huge distortion of the northern lands, which just, yeah, isn't an accurate view of what Canada is. But let's pull ourselves all the way out. Here's the Webb Mercator. That's what we're familiar with, particularly on Google, if you've just got it on the standard mode. And again, great way of actually visualizing planet Earth. Here I'm just using DecGL. I'm using the map deck wrapper to DecGL, just putting I think it's a Google map in the background, and then putting a couple of polygons on top. Polygon for Greenland and a polygon for Algeria. I think most people know that Greenland isn't supposed to be that big when you look at it on the globe. But what's really interesting when you start actually doing the analysis, we'll use a spatial type function SD area, and you can see that actually Greenland is smaller than Algeria, slightly longer, but a lot narrower. And again, it just simply shows how distorted things get, both north and south. There's always a bias in the northern hemisphere because there's a lot more land in the northern hemisphere. So again, it's just being aware of that. What are you trying to show? Is it better to just break things up and show things on different pages? Is it indeed, in the digital world, better to just simply show it? If you're showing it on the web, show it on a globe. Perhaps that's the better way as well. Another thing that I've played with is great circles. So great circles are good for plotting, again, on the globe, but then on the Webb Mercator. These are just flight paths. So like the red one's London to LA, the blue one is Frankfurt to Anchorage in Alaska. And I remember many, many years ago, sort of like being like amazed at or puzzled by the fact that why is it when I fly to LA, I'm hitting Greenland and then going back down again? Well, because when you put it on a globe, you can see clearly why that is. I know there's a number of different factors why flights go a particular route, but in terms of shortest distance, they trace a great circle. And the shortest distance between the UK or London and LA is this red line. But of course, when you put it on a Webb Mercator, that is a straight line. That's not the shortest distance. That is, and then of course you've got the Frankfurt to Anchorage, which is even more extreme. So again, you know, it's just understanding that. I know I've seen in the past where people have done kind of concentric circles, saying like how far, 100 kilometers, 1,000 kilometers, say from Paris, and they've done concentric circles, but they've done it on a flat map, which isn't right. Of course, the concentric circles will have to distort as you go further north. So again, it's just being aware of that. Okay. The stuff that I do commercially, and I have been doing over the past few years, one of my clients is a prop tech company. So Molior, they basically look at areas, particularly in London, but also now the UK, areas ripe for residential property development. And so they have a nice two-dimensional north-facing map, and with lots of different filters and etc. that allows then their customers, who could be investors, property developers, etc., to identify areas that new residential developments, new large residential developments could could take place. They started off with just dots on the map. Then they wanted polygons, you know, actually sort of drawing the polygons. So what I did was give them QGIS, and then that allowed them to then start actually draw. It was connected, QGIS connected to a Postgres database with PostGIS. So it allowed them to very easily capture the actual site boundaries, but then also capture the boundaries of what the proposed building footprint could be. And then they would assign things, certain attributes such as residential tower height. And so that then meant that we could very easily then bring that in and visualize it. Again, this is on MapDeck, DeckGL. But the great thing about DeckGL is, and I don't know how many other sort of libraries out there do this as well, but certainly DeckGL, you can flip into 3D. So because we're also capturing the height values, we could very quickly do things like this. Now, again, 3D, we don't want to do 3D just for the sake of it. But what we found is with this, because we are talking about buildings, and these are buildings that haven't been built yet, why not actually extrude it out the ground? Why not show it in this way amongst other buildings that are around it? We further then sort of like played about with the styling. It's all very Minecraft-like, but this is actually taking advantage of polygon Zs. So rather than just having an X and a Y, we've now got the Z value, so the value above our reference point, not sea level in this point, but just simply, so then we could stack all these polygons on top, make them slightly bigger, and then give the illusion of storylines. So the idea was just like the end user could sort of pan around the map, they could search their area of interest, and then once they were interested in a particular area, I don't know, London Borough of Sutton, they could click on it, and then things then could actually extrude out of the ground and just bring the data a little bit more to life. And then, of course, because we're capturing this all in a database, this is very easy then to bring out into, like, you know, huge new development areas. And this is just one of the examples that we've been doing. So this is actually now an actual data card that we brought out, highlighting this particular development that is currently being built in, where's that, Birmingham. Go to the next one. Right. The other thing that we've been doing sort of lately, very excitingly, is, and this is out of the fact that, going back to co-working spaces and how good they are. So I used to be a member of the Fusebox, now here at the Loading Bay and here at Eagle Labs. And you end up sort of talking to sort of like lots of different people that are doing different things. There was a lot of stuff, is a load of stuff going on in virtual reality and Unreal and Unity, those 3D worlds. And so we then started to look, I saw Llewellyn, who used to work here, was doing architectural drawings, of new builds or buildings that are yet to be built. We're just wondering, is this a geospatial environment we could use? Does it actually have, you know, geospatial plugins? It turns out that Unreal's the, you know, the games engine. I'm sure some of you used it. Cesium allows us to do exactly that. Cesium gives us, for instance, Bing Maps on the ground, or Google. It gives us a terrain. You can't really see it here, but this is Brighton represented. You can see the hills as well. And it then allows us to, so what we decided to do was actually do some sort of like very high, come back, there we go. Very sort of high sort of definition. This is Preston Park West, it's almost built now. It pretty much looks like that. Representing that, again, giving sort of people another idea of what this data is. We've started putting billboards in place with information on them, just making it a little bit more fun. But then further, I've got another person that's doing, he's working on a Python and Unreal blueprint pipeline, very complex. But all of our lovely data that we've captured, we can also bring into this Unreal world as well. So this is Paddington Green up in Paddington. But these are the buildings that haven't been sort of styled in a photorealistic way, but we're bringing them in and then extruding them out the ground. And we've got that now sort of working as a whole pipeline, which is really cool. So again, we're not necessarily giving this to the end users. We're doing these as videos because, again, the idea is that the end user wants a 2D north-facing map. They get very confused if you don't do that. But when you start zooming in, then you can start showing this stuff. So it's been a really, really interesting journey. The last thing I wanted to talk about was this is something totally different. Contour map, but a contour map of London based on property prices. So we were just downloading data from HMRC, and that's and then geocoding it. So essentially, we've then got a whole load of dots covering all of London, and then we need to make that into a surface. So, and using QGIS, that was, well, it was trial and error, but it was basically a process that we had to go through. So we clustered the data, got rid of the outliers. Then we've got the triangular irregular networks. So then that means that all of the points then go to the nearest neighbors. We create a triangular surface out of it, which becomes very detailed. So then we use a Gaussian filter to smooth it all out. Obviously, there's a lot going on here. And then we extract the contours and then cookie cut it to London. So that's kind of, again, something we've been working on. Clearly, obviously, central London, you pay more pounds per square foot with your data. Again, experimenting with 3D just to see. What was really interesting when we did flip it to 3D, we're not giving this to the customers, but it was to show our immediate customer where the literal data spikes were. So you expect a spike to be in central London, but we didn't expect it to be up there. And it was clear when you look at it from this point of view, but not necessarily here. And it turned out that that's asking price data. There's a developer here that was over-egging the asking prices. When the actual achieved prices came in, that spike went. And so that's all in QGIS, but of course, QGIS, a lot of what it does is Python in the background. So you can easily lift a lot of this stuff and then script it all. I'm in the process of doing that with R at the moment as well. So yeah, just finishing up, what next? Current inspiration is I'm trying to look at OpenGL, and so R has got a ray shader package that kind of hooks into that, so you can do these really highly stylized maps. This is not me. This is, oh, it's come out as a different one. Research Remora is the guy. He does these on Twitter and Instagram. I went to a conference a while ago. You remember this, Phil? And basically, there was a map of Chile. And they had to chop it up into two, sort of, because it's so long, they chopped it up into two things. And I thought, oh, that's a bit naff. Anyway, this is a good representation, obviously, of Chile. You can see the whole country, and it's so that's something that I want to play with. No customers asked for anything like this yet, but it looks cool, doesn't it? Craig Taylor, he's one of the original kind of inspirations way back 8 years ago. Went to a talk that he did. He's also known as Mapzilla. Definitely go there. He does all sorts of amazing visualizations with data. He's got these things called coral cities, where he's taken transport data and then sort of like mapped out the distances that you can achieve over time, and so you get these kind of coral-like effect. Data meets art, but you know, why not? You know, the more we can make our data engaging, the better. So yeah, so that's it. Hopefully that gives you a bit of an intro into, well, certainly from my point of view, sort of what the journey's like. The key is know your coordinate systems and know your map projections, and know that you're going to continue to make the mistake again and again and plot your data. Visualize as quickly as possible. And what's really exciting is there a GIS community here in Brighton. I know at least 4 or 5 people now that are here, and I think there's a few others that I recognize but chatted to a few years ago. So there is a GIS community in Brighton. So let's see where we can take that. Thank you.
Wow, thank you so much for that, Sean. That's great. And yes, you have a GIS community here in Brighton, because half of you responded that you had worked with geographical and mapping data before in a work setting before. So there's definitely appetite for it. So please do try to use this venue as an opportunity to network around that. We have some time for a couple of questions, and let me just first ask if the remote audience have sent us any to work with. Okay. Does anybody in the room have a question for Sean? Okay, I think I saw that hand first. So hello.
Gate crashing slightly because I'm actually here co-working, but it's fascinating. Thank you. Yeah, sorry. Lots of great stuff around the built environment. I wonder if there's anything that you could overlay in terms of how people behave in the built environment, you know, journeys, things they do, buy, etc., etc.
Yeah. So what, you know, transport data, sort of people movement and things like that. Yeah, I mean, we haven't been asked to sort of like look at that. I know Craig Taylor that I just mentioned, he does a lot of that lovely transport stuff. Again, a lot of it is down to the quality, again, of the data. It's like, great idea. What's the quality of data out there? How much data engineering do we need to do in order to make it look good? But we did some behavior. We did some stuff a few months ago on, say you're looking at a particular site in London that could be ripe for 20-story development. And one of the key factors was this concept of a pint of milk. What that meant was, how far does someone need to walk from that proposed development to buy a pint of milk? Could be a convenience store, could be a petrol station. But the important thing was, you've got to be able to buy a pint of milk within walking distance. And so we started bringing that as point data in, and just sort of like just simply showing that on the map. It's like, yeah, too far for a pint of milk at the moment. We need to do something about that. So.
Thank you for that question, Michael. And yeah, I see two questions here from, well, we have two Nigels here asking questions. So let's start with the first one.
Hi, fantastic talk. I love maps too. Really quick question. How much is the error of the British National Grid? And presumably the corners are the worst culprits.
Oh, well, I mean, if you're working in British National Grid, and you're just working in British National Grid, you haven't got any errors, because it's all, it literally is meters from that west of Scilly Isles origin point. As I understand it, and there's other people that probably will possibly know better than me, depending on how what you're converting from. If you're getting it from Ordnance Survey, you should be spot on. If you're getting it from somewhere and then it's been converted, because I've seen it where, you've got something that's been given in even latitude, longitude, you've got to know what projection it's at, because latitude, longitude can be different depending on what system you're using. The same latitude and longitude can actually be different. So, and I've seen it before, I've done it myself, where I've had to convert something from lat long to British National Grid and then convert it back again, which isn't, and you can clearly see, you plot it on the map and everything's like out by kind of a meter or 50 centimeters or something like that. So your precise answer to the question, I don't know, but yeah, you got to watch it, absolutely, particularly when you're converting from one system to another. Yeah.
Hi, Sean. Thanks for the talk. It was great. Just a quick contribution. So I'm off to China shortly, and I don't know if you knew that they used an obfuscation algorithm on the GPS coordinates there. So if you ever have those coordinates, sometimes, you need to license that algorithm basically from the Chinese government in order to know the exact location. The impact of this is you use Google Maps and you're trying to find a subway station and you end up in the middle of a field half a kilometre away.
Right. So Google Maps is wrong.
Right. Something to bear in mind if you ever deal with any Chinese data. That they have this lovely way of obfuscating.
I mean, Ordnance Survey data can be very expensive. There's a lot of free stuff there, but if you want, for instance, we get we use with the client address space plus and address space premium, and for the whole country, I think that's like 10 grand a year. So if you want that sort of ultra precise, then it certainly does sort of cost you. So I guess the Chinese are going one step further and saying, no, we're just going to scramble the data until you pay us. Yeah, interesting.
Cool. I've got a question. Sorry. I've got a question online, which is, are you doing any work around commercial or industrial property mapping from Ashish?
Oh, right, yes.
Sorry, I just thought I'd include their name. It'd be nice.
Yeah. So the client that I'm working with is London and the regions. We're really focusing on large residential developments that could be on brownfield sites or sites that have currently got a warehouse, sites that are currently offices. That's the big thing at the moment. So so that's the area that I know. So London, Birmingham. London is, it's ridiculously huge compared to the rest of the country. A London borough is bigger than what's going on in Birmingham, for instance. So the focus is all there, but there are a huge amount of, particularly in the build to rent market. So these buildings being built just for rental. That's appears to be the big growth at the moment.
Cool, thank you.
I feel like I missed a question in this area. Did anybody else ask a question or raise their hand that I missed? Very good.
Hi, very interesting talk. I was wondering whether you played at any point with financial data, putting it on top of geographic data. I've seen some proprietary data from Lloyd's only at aggregated level, and in my head, while you were talking, I was thinking,
Right, yeah, interesting. What, as in sort of, you mean like demographic data, what people
No,
learn, or, you know?
basically Lloyd's, banks like Lloyd's have information on how much money you make, where do you shop,
Right, yeah,
where do you
yeah.
buy, what brands do you buy.
Yeah, so we haven't done
You
that,
could
but
say
again,
things
it's
like, in this neighborhood, people are buying more Marks and Spencer than in this other.
right,
or,
yeah.
I don't know.
No, absolutely fascinating. Yeah, if we, it would be good to be commissioned to do something like that. Absolutely, because again, you know, all of these wonderful diverse data. Once it's geocoded, you can do a lot with it. So yeah, but not done anything as such.
I have. I have, yeah. So I used to work for police force, and they buy lots of this data from likes of CACI, CACI, whatever you want to call them, and Experian. So it's more about knowing which are areas where people have certain habits. So, you know, you've got to be careful what you say, but where people have Sky subscriptions and have a lot of satellite dishes on their house, they maybe make some assumptions about these people, and more about knowing where to put police in situations as well, where people will have more expensive cars, it gets a certain sort of criminal around there, that kind of thing. So police certainly do use it. They probably can't afford it now, but they did when I worked for them.
All right. Well, that's fantastic. Thank you all for your questions. That really keeps a very interesting element of these meetings together. So we're very grateful for you for asking questions. But now, let's give Sean a warm hand in gratitude. And Sean, you said earlier, and I absolutely agree. Isn't this cool? It is very cool, but it's beyond cool. It's more than cool. That population spike graph of Chile, for instance, it will tell you how the population of Chile is distributed. You learn that so much faster. That flyover those buildings, that's just like having that scale model. But it scales. It's a scale model that scales at internet scale. You can share that across the internet. People can see that. They don't have to be in the same room as the architect. And it's much more informative than static photos can be. Sean's, second or third slide had some locations in Northern Ireland appearing in England, Wales, Cornwall, some area. That's because initially Sean had to deal with spatial data quality. And so here to teach Sean and the rest of us all about spatial data quality is Robin Burchfield. Thank you.
Hello. Yep, maps are very cool. GIS is new rock and roll, I'd say, but it's more probably Coldplay style than Led Zeppelin, but yeah, we love it. Okay, this is me. Okay, so I'm not going to have all the fancy visualizations that Sean had, but I suppose I'm going to be a bit more dry. They're great, but the underlying data needs to be correct. Otherwise, they just give the wrong message. Hence, things that should be in Northern Ireland not being in Northern Ireland. It's a common theme. So who am I? Yeah, so as I say, I love maps, kind of how I got into this. So over 20 years doing geo stuff, multiple sectors. So just chatting to the chap at the back there. I've worked with police. I've done gas utilities, water utilities, rail transport, currently doing a bit of defence work. And there's another one I've forgotten, Environment Agency as well. So yeah, spread myself around a bit. Geographer at heart, so that's how I got into this. But like lots of these roles, when people say, what do you do? The first thing I say is I'm an IT consultant. So I've accidentally fallen into IT. It can't be avoided, but I'm not I work with people and you just say, you know, what have you been doing all week? I've been coding. Oh, what are you doing at the weekend? I'm doing coding. I'm not one of those people. So I get away with pretending what I know I'm talking about, basically. So yeah, I'm not a coder. Various geo job titles. What I mean by that, I had a period when I was contracting. So I've had quite a few roles over the years because geo is quite a niche skill. All these jobs have different flavors. So quite often there'll be a project to roll out somewhere new at an organization. And there's that spatial aspect. So the project, I quite often get brought into projects and they're halfway through, or was when I was contracting, where they suddenly need someone who knows geo, who knows spatial. They go to an agent, they trawl LinkedIn, you know, not many names come up. And then people like me go along. And so I've had to pretend to be, you know, a GIS engineer, a GIS developer, a business analyst. I was a change manager once, but there's always been that geo element. So that's my core skill, basically. But yeah, kind of a bit of a Swiss Army knife, which a lot of geo people tend to be, I think, unless they end up working at the same place for their whole career. But what is key is, yeah, data management, because geospatial data is just data with another data type at the end of the day. It's just got its own ways of being handled. So, you know, I call myself now a geospatial and data consultant, but I do lean more to the left on that one. Okay, so currently work for Envitia. They are based in Horsham. They came out of a sort of defense world, and they are very much geospatial. In recent years, they've had a big growth spurt going on, so they're going into a more generic data consultancy, but they are retaining that sort of geospatial flag. So yeah, just a quick little bit about them. They specialize in solving people's data challenges. So, you know, do come and find us if you need. This is not a sales pitch. As a company, not selling products. So it is basically, you know, we use anything that's available. If you've got tools in-house, great. We can use those or use open source. It's each case we look at it one by one and just try and do the best fit for the customer. And Envitia are also sponsors. This is a photo I took last time. It's not a great photo. There you go. That tells me Envitia need a more impactful logo. Probably more something like that, I think. That one stood out for me. But yeah, proud sponsors. Okay, so we've already had a bit on this. So yeah, this is just my take on it at a very, very high level. So any data that can be located on a map is geospatial data. So we talked about postcodes. Everyone's got a postcode, and that is a location on a map. A postcode is actually, most cases, a collection of houses down the side of a street. So if it's a point on a map, it'll be somewhere in the middle of that collection of houses, which does cause a problem when police data is being displayed to the public. It can put crimes on people's houses when it might have happened a little bit down the road. Rural areas, that's an even bigger problem because some farmhouse can get a lot of crimes put upon them just because something's been going on half a mile up the road in a car park at night time. But yeah, so that's why you need to be very careful. But that is geospatial. Once you've got it in that spatial format, you can then do different types of analysis on it. So what's the nearest so-and-so to my location, or how many of my point locations fall within a certain area? So Sean mentioned point in polygon stuff like that. You know, if you go and whack a road straight through somewhere, what other things is it going to affect? Is it going to, you know, you're trying to build a road through one of Sean's tall buildings and stuff like that? You know, that's spatial analysis. And vector versus raster data. So in Sean's example, we talked about vector data. So we got points, lines, and areas, and they can all be built up in layers and turned into a map. But there's also this concept of raster data. So that is an image with pixels. So all those pixels have color values that represent something. So as you zoom out, you'll see a map. So for spatial data, the vector stuff is a lot more powerful for spatial analysis, but lots of stuff does happen on raster as well, especially imagery that comes from satellites and stuff like that. Okay, so next up, I'm just going to show you, that was a spoiler, sorry about that. So very basic example. Do I need to share that, please? So I've made up some data based on Brighton postcodes. So we all see stuff like this. It's a spreadsheet. So on the left, we've got the postcode unit, and then there's a count for some sort of event that's happened at that postcode. So, you know, could be sightings of zombies around here, or I don't know, even worse, it could be Reform UK are canvassing, knocking on doors, even more scary. So we're used to dealing with data like this. So if we scroll down, which is that way, you see, yeah, lots of zeros in the counts, but as I get down, we do have some, I've color coded them so they stand out. Occasional one there, I think it was BM14. I've got a collection, a cluster. Oh, the colors are gone. Oh well, they were there on my laptop earlier. So we got some counts. So yeah, it's great. We've seen stuff like this before, so we can order it by count. And looking at this, you know, they're all in this sort of BM14 sector. Seems to be a bit of a cluster going on. So if I go back to my slides, yes, please, Oscar. So we can plot this on a map, and it just brings it to life a bit more. It just explains what's going on. So here we go. So this is all across the Brighton and Hove area. So for those that don't know, it covers Saltdean as well. So you can see these dots are, I've made them bigger where there's 2 or 3 events going on. So a bit of a cluster for where we are. And then zoom in a bit, and yeah, we can see we're there and we're surrounded by it. So can you lock doors, please? I'm not going out there. Whatever it is, it's scary. So that's very simple. And there's a famous map by a guy called John Snow in the 1850s. So he's credited as the first person who did this kind of thing. And there's a cholera outbreak in central London. And at the time, they didn't know how cholera was spread. They didn't know if it was airborne or from people touching each other or living in close proximity. So he took all the locations of people where they were living who were catching cholera at that time and mapped them. And he soon worked out it was coming from the water pumps. So he's credited as having the first sort of spatial analysis, but made a huge difference for epidemics and stuff like that, because he moved the cholera treatment forward loads by saying, yeah, you catch it through water, and then they knew what water pumps to treat and stuff like that. So yeah, quite a famous guy in the mapping world. A few examples of maps. So yeah, just ones I can find on my laptop, but I'm allowed to show. Yeah, it doesn't always have to be a geographic map. It can be things like this, which is more diagrammatics. This is a London Underground lines coloured in for whatever it was. I can't read that. And yeah, work orders on London Underground as well. Right, so it is very important. Why is it important? So as you can see here, you know, these guys have got good data quality. They're happy, they're young, they're good looking, they're vibrant. This poor guy, you know, but at the weekend they're all off to Lake Garda and going sailing and stuff like that. He'd be in Wetherspoons on his own. Copy of the Racing Post. So good quality data makes people happy, but there's more to it than that. So from a business point of view, data is typically used to drive business decisions. So commercially and operationally and all the logistics side of stuff. So if that data is not correct, it's going to give the wrong answers, basically. I might check my notes on this one. So for some examples of that, so yeah, recorded asset geometries on a map are used to make operational and commercial decisions. So, you know, how much revenue should a company put by in the next 5-year period to maintain an asset? You need to know how many they are, where they are, if they're linear assets, how long they are. So, you know, what's the meterage of them, stuff like that. If you're getting that incorrect, then those decisions are, they're going to hit you later on. In certain cases, operational efficiencies can be realized as your data improves. So an example of that is when I was at London Underground, I discovered how busy they are overnight when the lines shut down. They have teams going down there every night and doing work on sections of track. And when they plan this, they have to take so much equipment and all the teams down, and they've got quite a short window as well, and make sure everything's lit up and all the health and safety's in place. So you look at a map and think, right, we're doing these particular kinds of work orders where, you've got certain cracks in the track and stuff like that. Once you see it on a map, we've got, okay, while we're there, this would take us 2 hours. We've got another 2-hour window. But look, close by, we've also got these other situations where we can do this. So let's hit those at the same time. And then once we were able to, one of those maps I showed you before is what this was, available work orders. And they were making a lot of efficiencies, they found. They were actually having some nights where they didn't have to do this work because they were cramming more, sweating their assets more when their people were down there and using that equipment. Things like that. Avoiding safety cases, I suppose that's another London Underground example. So all their stations mapped in 2D. So this is zooming in really close so we can see rooms and the like, but they've got a big problem with asbestos. So when they're doing work and they're knocking down walls and stuff like that, when customers aren't in stations, they need to know where that asbestos is. So if they're, if you're knocking through this wall and there's asbestos right on the other side, the map can tell them that. If you see that in tabular form, it's really hard for someone to analyze that and pick it out. So it's just visual, it's right in their face. There's a big warning button to go, asbestos here. Make them think twice about it. So for this last point, I think in my experience, many organizations, or maybe it's what they want to think, they assume their data quality is pretty good. But it's only when, I'll say, a third party comes in and takes that objective view, there's always a lot of surprises when you point things out about what's going on. So yeah, don't assume your data quality is good. So how are these issues caused? So as what's already been mentioned, projection issues. So yeah, this is my take on it. Yeah, this is the world with different projections. So you can see Africa, it's pretty big and long there, but here it's about the same size as Greenland, which I think we know is not true. I suppose another way of thinking of it, if you had an orange and you draw something very intricate across that orange and then peel it and try and lay it flat on the table, it's not hard. It's not easy. I mean, it is hard. you get gaps between it, but if you're trying to stretch it onto, say, a rectangular piece of paper, you're going to have to stretch bits of that orange and move it across. And that's, you can quickly understand how you go from spherical world to flat world, how many problems it can cause. So data's captured in different projections, especially since Google came along. There's a lot of lot-lang, latitude and longitude, latitude, which way around it is. Yeah, whenever I put it on a map, I know whether it's right or not. If it's in the water, then I've messed up. Yeah, so that's quite a key thing, because before that, yeah, I was working pretty much in British National Grid, and as Sean mentioned, that is built for England, Scotland and Wales's use, and because they're kind of small enough, you can get away with it in most cases. But London Underground actually have their own version of British National Grid that just covers the London area, where they've made it even more accurate, because they found there was problems there. Especially we've got things like the Crossrail project, where they're boring tunnels, where they've got like a meter's gap before they hit the Northern Line. It's got to be millimeter accuracy. But that's going a bit beyond geo. I suppose that's more sort of 3D construction world. Taking data from third parties, yeah, that's another thing I've witnessed quite a lot. So you get these big organisations, and if you're buying data from your Ordnance Survey, it's good. I think that's one thing. In the UK, we can say is world class. The Ordnance Survey, absolutely brilliant. But there's lots of other places, and my postcode example, you might have someone that's selling you data and it's based on postcode, and your assumption is there's a dot on top of a house, it means that house, but it could mean a whole area around that house. It's just knowing that, really, and it's how you're using that data beyond that. Automated processing, so lots of automation gets done on big data sets. I think this is from the Environment Agency have had, where they've taken their data and got a company in, maybe like Envitia, but it wasn't Envitia, who have run a load of automation to create new layers based on their data. And it's come out mostly correct, but you get some very interesting things in certain areas, where some estuaries have got interesting shapes. It can just mess the data around. And hopefully I'm going to show you some of those in a minute. Data generalization. So this is if you've got a very intricate line, if you're zoomed in really close on a map, or a boundary, or like a river, for example. Rivers do this. There's lots of dots to make up that river. If you want to show it on a web map and zoom out, the reason they're so quick is they generalize that. So as you zoom out, they make that line more simplified by taking out nodes. So they're effectively changing the shape of it. But a lot of this generalized data then gets used to zoom in, and the River Thames is suddenly not going through London. It's just going south of London and cutting through the middle of it. And I suppose if you're at a mid-level, you wouldn't necessarily know it's correct. Most people know if the Thames doesn't look quite right, but not everyone does. So it's just a lot of assumptions are made, and manual data input errors. We're all human. I've worked at places where they have people sitting at desks that are just creating this geospatial data from scratch. You got with utilities and stuff. You got people out in the street. In February, taking a pair of gloves off, trying to draw something with a stylus on a device. People are going to make mistakes. So it's just having those proper gateways and testing QA processes in place to make sure bad data isn't getting in the system. So a couple of examples. This is made up data I've drawn, but kind of based on real world. So in this example, you've got an asset management company. These are all assets they look after, have to maintain. They need regular maintenance. They can sometimes fail, and when they fail, it costs that company loads more money to fix it. Plus, the assets are out of action, so they may have to pay fines, return money to customers, that kind of thing. So in this example, you've got two management areas. Management area, say north and south. They own assets that they have to manage. So south don't care about what the north do, and likewise. So where the boundaries have been drawn. So this is an example where, say, data has been aggregated from other data and automation has been applied to split the boundaries. You get these boundaries should be joined along the whole line, so it's quite clear you're either north or you're south. So you get examples where you can have a gap between the boundaries, and these are not always visible to the naked eye. I found sometimes some maps you have to zoom right in to see this sort of thing, but you can apply validation methods to find them. So you've got a gap here. So effectively, these 6 assets are not going to get picked up by north or south. They won't get maintained, and they're more likely to fail, cost loads of money, and then someone's going to get the blame and maybe even get the sack. So here you've got the opposite. You've got both boundaries are covering these 6 assets. So yeah, sure, they'll be maintained well, but they'll probably be maintained a bit too well. So someone could go in January and do the annual maintenance, and in February the other team go along and and waste some time basically doing that same maintenance. So things like that. These cost money. It could be safety issue as well. So if this was Environment Agency data, some of these assets could be pretty key for flood prevention. So if one of those fail, that could have catastrophic causes. So it's very important to catch things like this. Is another example I've seen. So duplicate geometries. So these, this is a river, and there's some river crossings here. This is using QGIS. If you select here, you can't see, it looks like there's 3 river crossings, but if you select this one, it's actually saying utility pipe 1, 2, 3, and the same there. So it's got different sort of unique identifier as far as the database is concerned. It's 2 different records, but it's got the same name. So you might have picked that up by looking at the non-geo data, but yeah, doing spatial analysis, you can quickly pick that stuff up. And I was amazed how many of these things I have seen at a customer site. I just didn't realize 2 of the same thing in the data. This is a very niche example. So actually interesting about the Ordnance Survey. So this is Ordnance Survey master map. This is much more expensive than the address data, by the way. But if you're a police force, you get it for free because taxpayers pay for it. So Ordnance Survey master map is absolutely brilliant. It shows buildings, gardens. It goes into that real detail. It covers the whole country, and it is constantly being maintained. So this is a gas utility I worked with. So let's say these are their gas pipes they maintain. And something that they spend a lot of time worrying about is if their maps give an indication that one of their pipes is underneath a bit of a property, all the alarms go off. They have to go out there immediately and investigate. They have to go and dig it up. And quite often they say, well, the pipe's not under the property. Oh, well, that was a waste of money, but at least we've ticked that one off. So with Ordnance Survey data, it's pretty much all done now, but over the last couple of decades, they've been doing this thing called positional accuracy improvement. So when they projected it and first rolled it out in their previous product called Landline, it came for Ordnance Survey Master Map, they found that there were some inaccuracies. So they've had to reproject it, and some buildings have shifted slightly. So this has been a big problem for local authorities. They've had to go through the pain of dealing with that. There was a company that had this tool that could do this for these, it was a good way of sorting out positional accuracy. It's kind of gone now. A company's called Envitia, that was it, yeah. So, but it's been and gone. That's not a sales pitch, believe me. So if they see on their map, so they can do spatial analysis, basically, select all buildings and select all pipes, and do they intersect each other? This one would come up as a failure. They need to investigate that. So in this example, it looks like the person's extended their property, and maybe some road builders don't always check what's underneath, but quite often it's just that the buildings may be slightly wrong, or their pipe actually exists here. But yeah, that is massive for these guys. They need to if they ignore that, they can get massive fines, and well, it's a safety issue as well, because it's gas running underneath someone's house. It shouldn't be. So how do you know whether your data quality is good or not? So yeah, moving away from spatial data, if you've just got tabular data in a database, lots of people would have done this. How you assess that data's complete, the mandatory values are there. There's not incorrect values in things that should be enumerated with set values, stuff like that. So all Geo is adding that new data type into the equation, really. So yeah, I'm not going to tell everyone how to do it. There's many things, many ways to do it, but what is key is the business rules. You have to understand you have to work with the organization to understand what their data should be doing, where might it be wrong, because they sometimes don't know. So it's a case of just profiling their data, going back and going, right, how about this? If it's, say, the Environment Agency have got a load of public safety trees that you're holding up banks of a river, and they're all in the English Channel, that data's wrong straight away. That's an obvious thing, but there's other stuff about, it should be within X meters of a water body on the base map. So you can apply some sort of validation rules around that. With that pipe example, gas pipes should not be running underneath properties. Simple. But how you do that, so tech, anything that's geo-enabled can do it. So we talked about spatial databases. So Oracle, it's got Oracle Spatial. You can do it in there. Same with SQL Developer, it's got a spatial side of it. Sean mentioned Postgres, it's got the PostGIS extension. So that allows you to do this sort of spatial analysis side. Loads of GIS products do it. So QGIS, as mentioned, there's a big company called Esri do loads. I'll mention R. Never used it, but I've heard R's pretty good. But this is it. ETL tool. So this, I'll just show you in a minute my favorite tool. I'm not saying you use this, but yeah, it's my way of doing it. So there's certain ETL tools that you can run these, you can build these repeatable processes to validate this. But typically, you're not just looking at geodata. If you go into an organization, they've got all their non-geo data as well. So I worked on a big project where geo was just part of it, but it was also just basically going through all of their databases and doing lots of attribute stuff. So my favorite tool, it's called FME. I'd quite happily spend every day for the rest of my career playing around with this tool. It's a nice canvas you can build up. There's hundreds and hundreds of transformers, and it's many different ways of doing the same thing. You can just build up these flows and test it, and it even shows you number counts as it's running, so you can see your data going through. It's built out of the geo world, so it's very geo enabled, but I love it. I just thought I'd put that in there. Once you've done the validation on the data quality, what next? I suppose, you have to go back to the stakeholders and say, here's the findings. This is how good your data is. It's, you thought it was 99% good. It's actually 87.2% good, whatever those stats are. But some of them might just be really, I hate using this term, low-hanging fruit. I've said it now. So really easy things to fix, things they probably knew about anyway, So yeah, that could be 10% of it. So suddenly you've made their data 10% better by doing something really quick and easy. But I suppose this is key thing is that the so what? Yeah, what is the impact if using a police example, if someone dials 999, the police have to get there as quick as possible. They need to know where to find that address. So I work for Surrey Police. A lot of the areas are quite rural. We used to have a farmer who was having his pheasants poached. So he would call the police a few times and then he'd start getting annoyed because the police would just turn up at his farmhouse. He'd go, no, it's in field number 5. That's where it was happening. So we ended up working with him to create specific bits of data. But when you call 999, say this location, and people would turn up at this gate post, not your farmhouse when all your pheasants are gone. So that's the impact of it. I suppose that's only one farmer, but in the EA world, those embankments of rivers, if they collapse, people can die basically. So that's the so what. So that's where you prioritize each one. Which are the most important things to fix, and also why is it happening in the first place? So quite often it's data capture side of it, where the data is coming from. So I'm going to pick on Surrey Police again. So they used to have some guys who record, these guys are long retired, used to record road traffic accidents or road traffic collisions, can't remember which is the right way to say it these days. And they used to have this old A to Z of Surrey, and they'd get the address and they'd look at the grid lines, and they would then write down the coordinates, eastings and northerns, hopefully get it right around. But for some reason, they always rounded it down. And when we saw this, go, why are you doing that? And then, we've always done it like this. And it looks fine in their spreadsheet or Microsoft Access as they're using then. So I said, right, give me your data, we'll put it on a map, and we'll see where most of your accidents are happening. And they're happening in the English Channel. And I don't know if you know Surrey, but it's landlocked. So it was basically the 500,000 to 150,000, the corner of 100 kilometres that covers Surrey and Sussex. For me, that's like, well, why are you doing this? But for them, they just didn't realise. So it's only when you showed it on a map and go, look, this is the actual data you're recording here. So it's not helping. The nearest place is Littlehampton. It takes a boat to get there. So fixing it at source is the best thing to do at this point if you know why it's being caused. And then from that point, how about cleansing some data? So you've got a lot of data that's got into system. It needs fixing if you can. So in my example, this is using my favorite tool, FME. So FME, you can build up flows, which basically you can close these. You can either take this boundary, lock it to that one, or vice versa. And same here to make that a continuous line. But you need to apply some thought. Do you draw the line there or somewhere in the middle? So how I got around this in this example, I'm going to stand over here now, is, you've got north and south. Who owns these assets? 6 assets there. The approach I applied was to also look at what attribute data are on these assets. So some of them would say they should be in north or south. They'd have some legacy attribution in there. So it's to calculate that. So out of these 6, 5 of them indicated they should be in north, not south. Then fine, we're going to close the boundary that way. We accept that one of them might be incorrect, but it's best endeavors, reasonable endeavors. So for this one, similar thing, close like that. Also, is there natural sort of rivers and roads that should have formed the boundary that's got lost over time? So it's just applying that sort of a bit of a critical thought of what's going in on there before you try and fix it. So FME, easily close that. I'm running out of time, so I'm going to speed through. This is another example where the Environment Agency had a load of river crossings and they have been captured as point assets. So they're just dots on a map, should have been lines. So this is probably more of a data transformation. So it's how do you turn these dots into lines? So using FME, did a calculation to work out for each dot, this is the riverbank data set they also had as a reference data set. They had this center line data set as well. So to calculate what's the nearest point of the left bank, what's the nearest point of the right bank, put points in there, join the line up, and then remove that middle point. So in this lovely example, you can see these all make nice clean lines, and they've got proper linear assets, tell them how long the river crossing is to help with those commercial decisions. That's all well and good, but you get edge cases. So this is from that same data set. We also had ones that just kind of all got a bit of a mess. You know, data can be messy. They're covering the whole country. We had things here where the riverbank data just didn't exist. So my method basically would create this sort of crazy proposal. So I had to put some filters in there to say, you know, if the angle at this point is too acute or the line is too long, then don't use that previous method. We'll use a secondary method, which is effectively, for these two examples, we're just going to put in a 5 meter line. That's the most common bridge length according to the SMEs, and we put it over the river centre line where they exist and make it perpendicular to that river centre line. So do some angle calculations. So that was one of those big long FME workflows that would have gone off the screen, but I had great fun making it. So you cleanse your data, well done. The data's now gone from 80% good to 99.9% good, if you're lucky. What's next? Well, keep running those validation flows because it could get worse over time. You need to keep it good and explore those business processes to go back to the core, get those, you know, improve the data integrity going forward. And yeah, if you're getting third-party data in, just have some really good data quality gates, because if you're buying data, you shouldn't be buying rubbish data. It's going to cause problems down the line. Questions?
Yeah, thank you. Well, yeah, thank you for that, Robin. And now, Cam, do we have a question for Robin on the from the online audience?
We do indeed. It is that I've seen a lot of discrepancy with geocoders. How do you evaluate what type of geocoding services are good across different geographies, UK, Europe, US, etc.?
Any other questions? Yeah, that's a very open question, but you're right. It's like all things, there is a mixture of quality. I suppose it's just through using it yourself and seeing the output. I think that's all I've done with them in the past. Many times I've been given a spreadsheet of data and I've had to geocode it, and the quality of the data you're given, you just can't geocode it. Or you have to use alternative methods and just flag it to say, look, a lot of guesswork has gone in putting this location on a map for this bit of data. If a postcode is incorrect, you know, or one high street of unknown town, yeah, you just can't put it on a map. I suppose the geocoding services, yeah, I can't really comment on that without having used a load of them myself. I think it wouldn't be fair on these geocoders. But yeah, as all things, there's a mixture of quality out there.
Thank you for that question. Any question in the room? Yes, here, let me get the mic to you.
Phil, just a couple of observations really. I'm personally experienced. First off is the format of the data, you actually, or the user interface to it. Now, you specifically mentioned British National Grid, BNG. If you pick up your ranger map, you walk around the countryside with, it'll tend to give a map reference in terms of 2 letters followed by 5 digits and 5 digits, which is great if you're on BNG. It doesn't apply in Ireland where there's a single letter, but also you have to be aware that the coding of the 2 letters is not consistent around the place. UTM, which is used by a lot of countries in Europe, have a different interpretation of how you read those 2 letters. So if you're writing software that you want to map between the countries, you can't just lift it between 2 countries and say, well, there you are, go ahead. It doesn't work like that. One other thing is you can't move British National Grid, convert it into UTM directly by just sort of like saying, well, they're both grid systems, go. Because British National Grid is actually rotated by a certain number of degrees relative to, I suppose, UTM, purely because when they came to print the British Isles on or mainland UK on a piece of paper, it didn't fit, it sort of dropped off the edges. So they rotated it round so it all fits onto a single piece of paper when printed upright. So when you do the conversion between the 2 of them, you have to be aware of that rotation coming into it. Okay, just an observation really.
Yeah, well, I've been fortunate. I've only had to use British data in my career thus far.
We'll have time for one more question and then move on to the next talk. Thank you, Harry.
Thanks. Hiya. I was really interested in what you were saying about the London Underground maps, and were you involved in drawing those maps, and what kind of maps are they?
So yeah, so they had two flavors of base maps. All their tracks are mapped, and every section of track has a code. So a station is a length, a segment of track, and then between stations is another segment, and they measure work orders in meters along that section of track. So it's called dynamic segmentation. When you draw that in geo, you're saying there's a work order between 100 meters along this track coming south out of King's Cross station, and this work order exists for 50 meters. And so that means, yeah, when you go down overnight, that's the bit you have to get your angle grinder on and polish whatever they're doing to it. But they also have these diagrammatic maps, a bit like the tube map we all see. You know, that is not geographical representation, because you look at it and go, oh yeah, Leicester Square to Piccadilly. Well, yeah, I'll have to get a train from that to get there and change at this other station where you could actually walk it in 2 minutes. So it's all spread out. It's all the stuff that's busyness. It's just to make it fit effectively on a bit of paper in the old day, but now on a screen. So Oscar's giving me the look, so I can chat to you afterwards if you want. What about that?
And let's give Robin a good hand again. Thank you for your talk. Thank you for your answer to your questions. And now, after an introduction to geospatial data and a discussion on the data quality issues and lessons on the different transformation systems, now let's see an application of data systems. So our next talk. Oh wait, where are we? So our next talk, we have two speakers, Hasan and Evren. Where am I? I'm lost. Let's give him a hand with their talk on empowering organizations through mapping.
I go first? Should I go first? Hello everyone, this is Evren. The worst thing about being last is not everyone is tired, but like talking after these two amazing presentations, you're always questioning your presentation. Why did I put that? Or should I like change my narrative? So thanks for like Sean and you, thank you for your presentation. So I'm Evren and Hasan is with me. Should I introduce you? Please introduce yourself.
Yeah. So I'm Hasan. I used to work for NeedsMap 2 years ago. Now I'm working for TfL, but I'm still a volunteer for NeedsMap. Glad to be here tonight.
Thank you. So maybe we can go on with the presentation start. So yeah, I am Evren. I started as a volunteer for NeedsMap. Actually, maybe a bit different from the others. I'm a political scientist. So NeedsMap is kind of a technology in which we are trying to create social good by using geospatial data. That's why our board picked a political scientist to run the organization, because like our job is to, as I said, how can we integrate the benefits of the geospatial data when it comes to empowering communities who are tackling with the social problems like poverty, education inequality, recovery after disasters, and so on. So, but the very original idea back in 2015, when we established NeedsMap in UNDP Social Good Summit back in Istanbul, it was very simple, actually, just to be able to match a person who is in need of any kind of material with the ones or institutions who can support them. So it was basically for Turkey back then. So very simple verification system, and then matching the people, and then tracking the, how can I say, the cargo processes, and then closing that case. How do you call it? Closing that case? Like if it is, closing the need. Yeah, closing the status. So I'm always learning the tech side from them. So that was the original idea. It still goes on, but NeedsMap has been, as you will see in a couple of minutes, it has been operational not only in Turkey anymore. We have offices in London, in Brussels, and also we did have a chance to have operations in Ukraine, in Morocco, in right now ongoing in Valencia and some other in Ethiopia and some other parts of the world. So what we do basically is like, maybe I repeat myself, but I think I should really put emphasis on that part. Our technology, our geospatial technology, doesn't mean anything without a human touch. What we are trying to do is to empower local communities, local NGOs, city councils, where to ease their operations in terms of volunteer management, asset management, warehouse management, if we're talking about a humanitarian aid after disaster, with the fastest and cheapest way possible as a non-profit. I forgot to say all the entities of NeedsMap are non-profit. It's a community interest company within the UK, a social cooperative back in Turkey, and the foundation in EU in Brussels. So this is where we are, and you have I'm sure you have seen the numbers, like millions of, I don't know, clicks, I don't know, visitors. We have like more than 100,000 members, and lots of projects, international projects and others. So after that, so we have some global awards that's through the showcases that we have, the cases that we have managed to create globally. But that story, as you can see in the maybe following slide, the other one, how do you say it? Proliferated, if you like. So it is through teams we have created submaps. So eventually, especially for us, after the touch of Hasan 4 years ago, the second version of NeedsMap, we started to create social maps as a service, or a service to create social maps. So then we have created 10 social solidarity platforms, 7 community platforms, 5 disaster management platforms, 15 campaign management platforms, and a social marketplace. It is kind of like Amazon for goods. So it works like any kind of retail or online platform, but it is only for good after the disasters or to tackling the poverty. So they are, as you can see, in the areas of no problem. I'm experiencing first time as a DO presentation. I'm presenting everywhere. Like tomorrow I'll be going to Brussels for the data week. So, but this is the first time, thanks to Hasan. So these are the main areas that we operate, that you will see how we implement them in the following slide. But now we're going to, since we're going to the tech side, the floor is yours, my friend.
Yeah, it's been 2 years. I haven't been exposed to this kind of projects, but I will try to do my best. So, well, hopefully we had some presenters who had mentioned what geospatial data is. So I don't need to start with Jon Snow's famous color map. So I'm going to continue with the why geospatial data in context of humanitarian and disaster management context. So why geospatial data? Geospatial data can provide lots of evidence-based insights tied to specific location, as well as addressing long-term development goals. Also, geospatial data, with geospatial data, we can undermine and we can learn some kind of patterns from the data. With a tabular data, we cannot understand the actual patterns, because we know that from the geography's first law, the Tobler's law, the things are closer things that are closer are more related than those who are further apart. So if there's a clustering, that shouldn't be random. So with this kind of analysis, we can exceed our understanding of data to assessing our damage in context of damage assessment, or in context of humanitarian aid, for instance. We use this kind of information to start new corporate social projects with different organizations. Say if you have many NAPI needs in some certain areas clustering together, which means there is a problem in those areas. So we approach some kind of corporations and we start new campaigns based on that data. It's just the basic filtering, but it helps a lot.
May I add one thing?
Yeah.
Yes. Actually, the idea, I forgot to say, the idea of needs map goes back to an EU-funded project, because like why it is important, because it is very important to affect the decision-making process of public institutions as well, in addition to offering CSR projects or sustainable projects. The main idea back then, 2013, I was also a budget tracking expert of an EU project based in Turkey. It was kind of creating maps to be able to track the municipalities like budgeting implementations. So we were back then giving some very simple, I don't even remember the GeoCommons, through a platform in 28 cities of Turkey to the members of the CSOs, how they can visualize the data, like the education data, the investment data, and then they can ask questions to the city council and the mayor by using those maps, by saying that, okay, here is my neighborhood and your investment on education is as such, but on the other neighborhood is that as such. So the idea was to like the social economic mapping, as Brussels says. And then we thought, since it is that much powerful to convince the decision makers, why don't we use that power of maps in the humanitarian aid and social solidarity?
Yes.
Just sorry.
So I will continue with the types of data that we have within the organization. So I think the most important data source we have is crowdsourcing through web-based forms. So as I said, we are collecting the needs or supports from people, from public directly. So we have crowdsourced data to empower communities and to increase the participation and provide insights. So these crowdsourced data then are verified and checked by our data team. So they check every single data coming from public, whether it is correct or not. They even check the location, address, and everything. So we verify the needs of people. So with crowdsourcing, we get lots of verified needs of people. So we then use this data and analysis to approach corporates to start new campaigns in certain cities. So we are designing tailor-made humanitarian aid campaigns based on the data we have and the analysis we are doing. And the other type of data we are using is coming from the field. So we have a team working directly in the field, and also we have some volunteers. We give some training to our volunteers regularly, so they know how to collect data properly. So in times of disaster, for instance, we don't use crowdsourcing. We use our experts to collect data directly from the field to damage assessment or collect needs of people in times of disaster. And lastly, we also use some open data sources to inform public, such as Copernicus data from European Commission to create risk maps, environmental maps, climate risk maps, and etc. So I will give some examples. So we have lots of projects, but we're going to give some examples. So the first one is disaster response map. So this project mainly has like 3 pillars. The first pillar is our external side, so the external part of story. So we collect data from Copernicus and other kind of environmental and climate-related sources to understand the risk of wildfires, floods, and earthquakes. And we also use social demographic information to join with those risk data to come up with this kind of basic statistical information, like the number of people who are affected by an earthquake or flood or wildfire, and the gender distribution, the number of children, an estimated number of elderly people, and etc. So this is made after the earthquake occurred on 6th of February, 2023. It was a massive earthquake who affected 13 cities in Turkey. So we use mostly open data sources such as OpenStreetMap, humanitarian OpenStreetMap, and we use some municipality data to come up with this statistical information. So this is just the external side of the story. So we also have internal dashboard where we manage our humanitarian operations. So this was like more high level statistical information, and this is a lower scale map showing the buildings who are affected or not affected. So this we had a partnership with OpenStreetMap, humanitarian OpenStreetMap. So we gathered this data from them, and we also have our data from the team, our field team. So we kind of overlaid those two data sets together to come up with this complete data set. So this map is showing the severe damaged buildings and the slight damage, the buildings who are damaged slightly. So as you can see, the loss of buildings were demolished in those areas. So we then can inform the municipality and other organizations to direct resources to those areas. So as I said, this was the first pillar, and the second pillar was more internal part where we manage humanitarian aid. So when we collect data from the field, we know that which areas are most affected and which materials are mostly needed. So this is an internal, but this is the last pillar, where we started campaign after the disaster. So this is a like post-disaster campaign where we 4 days. So this campaign started right after Izmir earthquake occurred in 2020, October. And also it was extended to the other earthquake occurred last year, 2 years ago. Yeah, 2 years ago. So the first idea was to create a web-based platform. So by the way, we are using hybrid model where we use Esri products as well as some open libraries such as leaflets. So this is a customized leaflets library where we use our Esri sourced feature layers and web services like WMS, WFS. So this is where we collect support for those who are the victim of the earthquake and whose flats are demolished during the disaster. So this was the pillar where we show the number of houses needed after the earthquake, the number of people providing rental support, the total support in Turkish lira, and the number of houses shared with those victims.
And this is also another example of how to convince the public authorities by using geospatial data. Apparently, Izmir Metropolitan Municipality first endorsed it, and like for the second, like the biggest, maybe that one is the biggest disaster in Republican history that we had 2 years ago. But they wanted to endorse it as well because Izmir is out of that earthquake zone, and they because of the power of the geospatial data, they put it on national TV. So the campaign went through the national TV for 3-4 hours, I don't know, with ministers and all actors and everyone. So by using the power of geospatial data visualization, as you said, we had a chance to convince the Metropolitan Municipality City Council, and then they spread it through all back then the opposition, opposition ranks of the national parliament even.
Yes, they were literally tracking this dashboard to see the number of people who provide support, the number of people who are affected and everything. And they were able to provide support in Turkish lira, or they can share houses if they have a vacant house. So this was a huge project, and almost every celebrity shared this campaign on their Instagram accounts and everything. Yeah, this was a huge project campaign back then. Yeah, so next map for Ukraine refugees.
Some couple of other examples, and we would like to open the floor for questions. So what I want to start from the field teams part, of course in Turkey, most of us are Turkish, and we have been working, personally, almost 20 years I have been working in social economic development fields, in somehow in activist side as well. And like, so I know almost like a lot of people in Turkish soil, if you like, all the like Anatolian soil. But when we go global, NeedsMap becomes more like a tool to empower already existing institutions and local communities. So that's our strategy, quote unquote, to globalization strategy. Wherever we go, we try to find a prominent local actor to propose them. Okay, we have such solutions that you can use both for your inner operation, like volunteer management, staff management, warehouse management, and asset management. And also, you can use it to promote your case before the international funding organizations or some big corporates, you name it, any kind of funding. So that is one of the example. So right after the war started, we were thinking about what can we do as NeedsMap, because Ukraine is our neighbor and very very old historical ties, and like currently like trade ties and everything. And we just started to our team started to create a map on the at least to see the way that the people had to move as refugees or IDPs. So we were trying to understand what to do, and then we as a team came up with, okay, we don't have it's a war zone first, and we don't have an operation in the Ukraine. We said, okay, let's try to collect the needs of the local groups at least and NGOs who are trying to help already to the refugees or the people who lost their houses. And of course it needs some sort of financial resource. And through our already existing network, I went to London back then to talk with some groups in European Bank of Reconstruction and Development, and talk. Well, we have such an idea, and they said, why don't we have a community initiative project within the bank, and then we can link it. We can link you with the Caritas Ukraine, and you can create dashboards for the usage of the Ukrainian NGOs. So that became like a facade. So it has never been public in terms of data entry, but NeedsMap for Ukrainian refugees became kind of a group of dashboards, which we tried to support the already existing and operational NGOs. So this is like one of the first international examples that we created. Maybe we can go through some other examples. So this is also, as I said, I can take any questions about the governance of the Ukrainian map. We have very similar, I think this is the last slide, but we have done the same thing with the Morocco after Moroccan earthquake with UNDP Morocco. Right now we are working with the Valencian regional government and the Valencia University because we have I think we forgot to add it. We also have an integrating WhatsApp chatbot solution to the map when it comes to collect the urgent needs after the disaster. So we are trying to integrate the Valencian case right now. So this is last example on how to show how we can ease the operational problems, if you like, burdens of the NGOs who, I'm coming from the same fields, who are dealing with financial problems. So this is Deep Poverty Network. You were with us when we were doing this, right? Yes. So this is because this is the reason that I put this is because my area of expertise in terms of academy is also poverty eradication, the social assistance mechanisms, comparative understanding of British, Turkish, and European social assistance. So I'm very much into poverty, the eradication process. So this is Deep Poverty Network is for Deep Poverty Association based in Istanbul. So they are working on door by door, child by child in the outskirts of Istanbul and least advantaged parts of Istanbul. So they came to us and we said that, okay, let's find a fund, a small fund, international fund, and we will do it for you pro bono. So we created a group of dashboards again, in which they can very much simply track their volunteers, track the families that they're touching, and track the, how can I say, the cards that they have been provided to be distributed to families. So what they're saying lately that before you, so this is maybe the last thing how needs is important, reporting of the humanitarian assistance. They are right now saying that before you, we were reporting to our donors in 2 weeks, like to collect all the data and like visualize it. After needs map integration, it's half a day. They can do the reports in half a day. So I think
as far as I remember, I think they were doing some surveys on outskirts of Istanbul. So we basically digitalized the surveys for them. So this is not crowdsourced at all. This is an internal dashboard with internal data collection process. So they have their own team who know how to do surveys. So we just digitalized the forms for them. So because before then, they were literally collecting data on paper, and they have to then give all of the data into Excel manually one by one. So after that, we digitalized the form. They were able to use that form on their phone, and then they were able to, and the iPad, and they were able to collect data easily. And as soon as the data is collected and verified in the office, the dashboard is automatically updated according to the information coming from the field.
We have created this same thing for 2 city councils for their social assistance mechanisms. I'm not sure whether they're using, but the NGOs are better, they're better to use it. So yeah, I think, yeah, that's it.
That was it, yeah. Thank you for listening.
Thank you.
Does anybody have a question to Hasan and Evren? Yeah. No, thank you.
Yes, thank you for that. Very interesting. Are you aware of Map Action at all?
Yes, in the
You
UK,
are?
yeah.
So
Yes.
I just wondered, yeah.
I actually applied for a volunteer in Map Action, but they rejected me.
Yeah, and me as well. Yeah.
I
When
don't
they
know
first
why. I have
started.
a very relevant experience,
Yeah.
but they rejected
Well,
me.
I applied when they first started, and I think they wanted like, lots of ex-military people and sort of SAS types. So I don't think I fitted that. mold
Yeah,
or
they're
whatever
doing
it's
very good
hardcore
work. Yeah,
rough.
but yeah.
But do you like work with them? So if you were to react to a humanitarian disaster, do you kind of help each other out with data and stuff like that, or you sort of separate entities?
We work with OpenStreetMap, humanitarian OpenStreetMap. Do you know OpenStreetMap,
Yeah, 'cause
humanitarian one?
I think they have volunteers who update OpenStreetMap, don't they? On,
Yes,
untouched
yes,
areas.
yes. Basically, they use like satellite imagery, and they use a bunch of like AI tools to classify the satellite imagery, whether it's damaged or undamaged. But we then use our field data to verify those, AI generated results.
Okay. Thank you.
Thank you.
Another question here?
Yeah, thanks for that. Really interesting. Less about the mapping, but really interested in terms of the engagement piece, in terms of the data collection you do. I've got experience of working with emergency services in the UK, so interested in, there's a real need for this and people understand it and want to work with you. But data collection is the last thing they think of. So just wondered how you came across that challenge and any experiences and any recommendations in terms of getting that by and getting the data. Thank you.
Especially, as I said, that's the hardest part was with like city councils, like local, not in the UK, but like in Turkey, like the municipalities. They have some systems of data collection like through their stuff, but I don't know, maybe I can say like bureaucratic conservatism. It's really hard to open that cooperation areas when it comes to data gathering. But like on the contrary, like coming from a political science perspective, I would expect maybe the vice versa, but the NGOs, like very small units, like with smaller capacity, quote unquote, they're more open to engage with other groups. Like you remember in Izmir earthquake, for example, we were very like badly needed data, because like the, you know, Twitter and like even the district that the Twitter was talking about that was like damaged was not true. But to be able to change that narrative, we contacted with some cycle volunteers. I don't know. Apparently, there were a group in Izmir, and they just came to our office in Izmir in an hour, like without any like objection. And but when it comes to municipality, it was not easy to convince our mayor before he sees that map. Okay, we can map it and you can visualize it before national TV, to be very honest. So each and every case has its own challenges, if you like, but like more public institution, maybe understandably, can be more conservative in terms of collaborative working, but and also international organizations as well. To be fair with the local public institutions, but what I very happily see in Valencia, in Morocco, that the civil society organizations, or not even a legal entity, the local communities are very much open when they understand and trust that you do something proper. That's why we are like, they are the boring details, but we are very much, especially in the Valencia case, for days and nights, the most important thing that I had to solve is the European GDPR. How can we compile with that? Which is understandable. It's not easy to, but you have to show it, because a Turkish entity came to Valencia to help us. Why? Are they trustable? That's the very valid question for Spanish national. So that's why you have to build trust around all your operations to be able to ease that challenge, if you ask me.
Oh, yeah, one more question here.
Please, more technical questions to him. just
Thank you. It was really
joke aside.
interesting. I guess I just had a question around representation and how, like, if you're using this data to direct resources to the right place, is that being directed based on the data that's been entered into this platform? And does that mean that certain people are not being represented in that analysis that haven't input their data into the system?
So, yes. So when we try to incorporate social demographical data into our analysis, it's quite hard in Turkey, whereas here it's pretty much easier because we have census data every 10 years at least. We try some methods to normalize our data when it comes to presenting our final static results, but actually our platform doesn't want to represent the whole Turkey, because we try to understand some kind of groups who are affected by certain kind of disasters. So it shouldn't be the whole Turkey in every cases, but I know what you mean. So it's quite challenging, but we try different methods to normalize that data to be more representative in whole Turkey.
Yeah, I would say on more like project management boring side, it is again tailor-made. So like it depends on the project that you create. Like the answer to this question is like, if it is like, for example, we have a project with the biggest cryptocurrency company of Turkey, Paribu. It is basically targeting the sports needs of all high schools in Turkey. So the universe is all high schools in Turkey and some representative teachers and headmasters in that particular district. So that's the universe. But what we have done with MasterCard's London's Trust Fund back in pandemic, it was like creating a social marketplace to allow you to buy something for someone else from a local shop rather than buying it from where you live. So back then it was whole Turkey, but we had to cooperate with more than, I don't know, 15 municipalities. We gathered their social assistance data and then designed the distribution route. So even now I talked about two different ways of defining the universe. So it's all about what's your priorities what's your objectives when you are creating project. The only different thing is the original needs map, as you said, and it's only applicable in Turkey, and we have a call center back there. Like the verification system is more Turkish law based, and it goes on in its own like path, if you like. Yeah.
Okay, I'll have one question for you finally. I just wanted to ask, so on your website, well, first of all, I see your a link straight to the work you're doing in Valencia there and the damage there, which is pretty striking to see. But also, I see that your website has a call for volunteers on it. What sort of training do your volunteers go through if they go ahead and click on that link on your site?
That's huge, actually. Very good, like very important question, because before the last year's earthquake, actually, I did think that we were prepared in terms of like our volunteers and their like capacities and like our like inner how can I say training mechanisms. And even before Hasan left, I always remember a personal story. With Hasan, we created kind of a handbook on what will we do if something big happens, who will call who, like, and do you remember?
Yes, I remember that.
And like on that, like I don't know, 5 a.m. I opened my PC, tried to find like, because Hasan was here, like where is that book and whatever, and I checked Twitter, so it's like 11 cities, and I said like forget about it, we have to do something else. And then we realized that we have to have a better volunteer management system. Thanks to them, right now we got a new funding from European Union delegation to Turkey. We now created a volunteer map per se. So it is designed with learning management system, just dividing the groups of the volunteers. Before we were giving a very general training. We were gathering them in the marathons, because we are doing marathon campaigns as well. But now, then we understood that we have to locate them. We have to understand their skills better. Like we have to understand which kind of institutions that they're working with. So we're now improving our volunteer platform in the partnership with more than 60 NGOs of Turkey. But currently we have very simple 3 categories. We have verification volunteers. We have like mapping volunteers, if you like, tech volunteers. We have field volunteers and office volunteers. We have 4 kind of volunteers, but our aim by the end of this year is to proliferate and open it to the Turkish companies as well, who are at least in Turkey, who are like grouping some of their staff as like volunteer groups. Yeah.
Well, yeah, go ahead then.
For both, I know whoever can help, Sheen or Hasan. So we as a AI transformer, we create custom products for different people. So currently we are developing an app for a NGO in India. So they do a number of similar work. So they do health camps, supplying food and whatever medicines, and they build roads with community helps wherever there are no roads. But now my problem, if you can help me, is from both of you, is like these are areas where there were no roads before. So these are like very remote villages. So there is no geo mapping of roads, but those are like tracks people are walking on, and these are hill terrains. So it's the topography is different. But now I need to map the route of the road that has been created, because when I'm doing point A to B, like it's a shorter distance, but it's actually, because it's a hill terrain, it's a longer distance. So is there a way that that we can capture that road that has been built, and what are the data points that I would require from the field to get that done correctly?
So I think first of all, you need to create your own network data set. So there are a bunch of different network data set available outside, like OpenStreetMap, free but not very accurate.
But these are not like, these are like
Yeah, I know.
There are no roads. That's why
Not-
people are building roads.
Yes, they are building roads. Yeah, you need to build your own network data sets. Yeah, that's
And
the.
what are the data points that you need to get from there? Like,
You can get like edges and nodes, like from open source resources. Like you can at least have the existing roads, like because they created that edges and nodes and the routes already. You can have it, and you can add your own paths and own edges and nodes and create the network data set from scratch. And you can run your the network analysis like catchment, travel time, whatever on that network data set.
Thanks.
This is French for me.
Well, excellent. Well, please give our speakers a warm hand. Thank you both. Thank you both. Can you hand it to Cam, please? This is too much. This is too much. Sorry, overload. Right. Now, quick question to you all: does anybody need the toilet? No. If so, can you hold it 5 minutes, because we have a surprise for you. We have a surprise extra 5-minute lightning talk on toilets and geospatial data. So, welcome to the stage, Ed.
Hi, everyone. Can you hear me? Okay, so find my nearest toilet. My name's Ed Dickens. I'm from an e-learning software development background. I'm a front-end developer. And during COVID, I decided to try and get work outside of the e-learning sector. So I learned React.js, TypeScript, Tailwind, Redux, mucking around with RESTful APIs, etc., etc. So I wanted to apply the learning that I'd done and take it to my next job interview, because all the e-learning that I'd done was in Flash, and how am I even going to show it to anybody? It's impossible to show to anybody. So I had a really bad idea. And from hearing the inspiring talks today, I realized that this is the much more interesting idea. However, I'll explain why I got rid of it. I'm a cyclist and I cycle around Brighton all the time. And when I go around certain routes, I would go, oh, there's a car parked illegally. Oh, there's another car parked illegally. And that's another car parked illegally. And I would know as I rounded the corner, there's going to be 3 or 4 cars all parked illegally in the same space every single day. And I started wondering to myself, is it the same person? Is it the same car? Does the council know that these cars are in these locations? Are they doing anything about it? So as I was cycling home one day, I actually invented in my head a way that I could get a phone, take a photo of the number plate, use OCR, map my location, because I was using location data on my phone, and then I could plot it onto a map. And then if I did this over time, I would create a heat map, which would demonstrate who was parking where. Was it the same person? Did anybody care? And I did actually build all of that, including getting the OCR data to go off to the tax office to find out whether the car was, I was chaining APIs together and doing all kinds of stuff. But I realized that I wasn't really sure what I was going to do with the data, and it made me look mad. And I wouldn't be able to talk about it in an interview because it's a very hot topic and it's very opinionated, and I just wanted a job. So I didn't do that. So I had a good idea. And it came from a meeting that I had at the council, where they have an older person's living organization. And one of the things that they revealed in that meeting was that they are cutting the number of public toilets in Brighton. And I said, well, if you want to put pressure on the council, if you want to put pressure on the people that do this, what you need to do is map where all of the public toilets are, and then say, this is how far all the public toilets are from each other in Brighton. So you have to walk 5 minutes or 10 minutes to get to the next public toilet. And I said, and then you compare that with Southampton or Portsmouth or Manchester or London. And so they said, oh, great, Ed's going to build an app for us. And then I realized I could reuse everything that I built for my parking grass application and create a public toilet finder, which was much easier to talk about in an interview. It meets a public need. It's non-controversial, needs no explanation. Everybody understands it immediately. And I could pretty much use all of the code that I had from my parking grass application. So very simply, and I'm afraid I'm humbled compared to all the amazing work that everybody's done, the humanitarian work that everybody's done, I created a map of public toilets in Brighton. And it was an opportunity for me to use Redux, and it was an opportunity for me to chain different types of data together. And it works exactly how you'd expect it to work. You open up your phone, you go to the website, you share your location, then you click Find My Nearest Toilet, and it tells you that Whitehawk Library is your closest toilet if you happen to be in that area of town. And that's it, basically. So I added some filtering so that you could find different toilets by different facilities they had there. And I just added more stuff so that I could demonstrate that I can muck around with data and talk about it in an interview. And that was it, basically. It's a lot of fun. The address is not here. It's locationfinder.bleepbloop.net. I think it's on an earlier slide. Maybe not. No, it's not. It's locationfinder.bleepbloop.net anyway. But have fun. It works.
Thank you. That was great. That was great. And we'll be sharing the URL to Ed's tool on our Slack page. Okay, so if you want to know. And yeah, with that, yeah, I guess thank you, Ed, and thank you all. Thank you to all the speakers. Let's give it up to all our speakers. One more time. So thank you for sharing their knowledge, for sharing their insights and their work. Introduction to geospatial data, the data quality issues with specific to geospatial data, 2 use cases. I'm going to have 2 both for public goods. Yeah, and so I hope that out of this comes a curiosity about spatial data, and especially geospatial data, and that we could have here a community built around it, and we might even be able to pass through map actions filters and be able to volunteer for them. But this is it. This is the last Brighton Data Forum event of 2024. Yay. Now we'll meet in 2 weeks and party to celebrate this great year that we just had. And I really hope to see you there. But if not, then we are already stacking up great ideas for 2025. So that's it for tonight. Let's go to the pub. We're going to Unbarred just across the street. Thank you for coming, and see you at the pub, I hope.